So in this video, I'm going to go ahead and give you another example of kind of going through all of this polynomial solving stuff, finding all the missing zeros. So what we're going to be working through today is how to solve to find all roots and zeros. I have an equation here for us to kind of look at. It's x to the fourth minus 13x to the third plus 55x squared minus 91x is equal to 0. We're going to go ahead and start by kind of going through each of these parts. The very first one is the degree. So we're looking at the degree of this polynomial. If I look, my highest exponent is a 4. So my degree here is a 4. The reason I'm asking you that question again goes back to that fundamental theorem of algebra that says the degree is equal to the number of zeros that we have. So since I have a degree 4, I'm looking for 4 zeros. The next two questions kind of go together. I want to know how many real zeros I have and then how many complex zeros I have. Okay, those are going to be found based on graphing this. So I have actually gone ahead and put this equation into my calculator already. I'm going to go ahead and then graph it. This graph is a little bit tight. It's kind of hard to see. I do have this little piece down here at the bottom, kind of right along the x-axis. So I think there's actually a line kind of coming through right about here. We'll make sure we check out that point in the table here. And I also have this point over here on the side. Looks to be at about 7. But again, we want to check those in the table. So let's go to the table, see if we can find those 0. Okay. If I look at the very first row here, I actually have a 0 there. Okay. I know that I have a 0 right at 0 actually. And that's where I saw in the graph I'm coming right through the x-axis. But I'm not, can't see the line because it's just lining up on the axis. Same thing at 7, I have another 0 there. So I actually have 2 real zeros. I can see those both on the graph. I'm crossing it 2 times. So I have 2 real zeros. That means that of my total of 4 zeros, 2 of them are real. So 2 of them are not real, or they have to be complex. So I have 2 real ones, 2 complex ones. Now I have to go ahead and solve those. Okay. So to actually find the real zeros, that's what we just did in the table here. We found that I had a 0 at 0 and I have a 0 at 7. So I'm going to go ahead and list those 2 zeros here. I have 1 at 0 and 1 at 7. Now I can go ahead and start to find those remaining zeros, and this is where division is going to come into play. So I'm going to go ahead and get my calculator out here so we have some room. The first thing I need to do is I need to get these 2 zeros here written as factors. So the factor for 7 is going to be an x minus 7. That one's pretty straightforward. The factor for 0 is a little bit trickier. Typically we would write it as x either plus 0 or minus 0. But in the end, the plus or minus 0 isn't going to do anything. So I'm going to go ahead and just treat it just as an x. And that's a little bit different than any we've seen in class. Okay, if I go ahead and go from there, though, I can go ahead and distribute that x to both the x and the negative 7. X times x is going to give me an x squared, and x times negative 7 gives me negative 7x. So that is now the thing that I'm going to go ahead and divide by. That's my divisor. So I have an x squared minus 7x. We're going to go ahead and divide that into x to the fourth minus 13x to the third. Plus 55x squared minus 91x. Now I am missing my regular constant term here, so we could add a plus 0 to the end if we need to. In the end here, we're not going to actually need that line or that term, but we'll go ahead and throw it there just for consistency. Okay, so let's go ahead and start to solve this. I have x squared minus 7x, so I need to go ahead and figure out what I need to multiply x squared by to get x to the fourth. Well, I know I need to get 2 more x's, or I need an x squared there. So x squared times x squared does give me that x to the fourth, and x squared times a negative 7x gives me a negative 7x to the third. Okay, now that line there, because this is our division, we need to subtract that away because I've now dealt with those pairs. So our x's to the fourth cancel, and I have a negative 13x to the third minus a negative, which is really like adding a 7x. So negative 13 plus 7 is going to give me a 6x to the third. And that one's going to be negative because I have more negatives here with the negative 13x to the third. Okay, next thing I'm going to go ahead and bring down our 55x squared, which is then going to help me to figure out what I need to multiply by to get x to the third. So I know I need an extra x and I need a 6, so we're going to call this negative 6x. That's going to give me negative 6x to the third then when I multiply by x squared. Negative 6x times negative 7x is going to give me a positive 42x squared. Okay. Then from there, we can go ahead and look at our next piece. And if I look, I'm going to subtract that line. When I do that, our x cubes cancel. Then I have 55x squared minus a 42x squared, so I am going to actually subtract these ones. That gives us a 13x squared minus 91x. I'm going to bring that part down. Okay, so we're getting to the end, but we still got to look, what do I need to multiply x squared by to get 13x squared? Well, that's got to be a positive 13. So we're going to put the positive 13 there. That's then going to be multiplied by the negative 7x as well. Negative 7 times 13, I just did this on my calculator, does give you a negative 91x. Okay, so when I subtract that, everything here matches, so these are just going to go ahead and cancel out, and I get a remainder of 0. Okay, now if you really want to bring down that last 0, I just still have a remainder of 0 and 0, so our remainder is just 0. Okay, this one on the end didn't actually need to be there, because I got a remainder of 0 before I got to that point. Okay. However, I'm not done on this problem, because all I found now is I have this quotient at the top. I have x squared minus 6x plus 13 that I need to still solve. So I'm going to throw that in the middle here. X squared minus 6x plus 13 is equal to 0, and I need to solve that. Now this one's a little bit different than any we did in class as well. It is similar to one of them on your worksheet. If I have that x term in the middle, I can't just use square roots anymore. And I'm not even going to try and factor this, because if I could have factored it, I would have solved them as real zeros on the graph. Which means the only other way we have to solve this is using our lovely quadratic formula and going with a, b, and c. So let's go ahead and find a, b, and c, and we'll plug them in and figure out if we can simplify this thing down. Okay, so my a value here is 1, my b is negative 6, and my c is 13. If I go ahead and simplify from there, I'm going to have a negative 6 plus or minus the square root of b squared, which is negative 6 squared, minus 4 times a, which is 1, times c, which is 13, all divided by 2 times 1. Okay, now we're ready to go ahead and simplify that one again as well. So a negative 6 just becomes a 6, plus or minus, I'm going to type this whole bottom portion into my calculator. So I'm just going to do this down below so you can kind of see it here. I'm going to take the negative 6, I'm going to square it, I'm going to subtract from that 4 times 1 times 13. Type the whole thing in, gives me a negative 16. So that tells me I still have the square root of a negative 16 over 2 times 1 is just 2. Right, if I keep simplifying, I have 6 plus or minus square root of a negative 16. Well, the negative is going to become an I. Then I have a square root of 16, which is just going to give me a 4. So I get 4i out of that, all divided by 2. Now I still can divide by the 2 to both pieces here. 6 divided by 2 is going to give me a 3. 4 divided by 2 is going to give me a 2 with the I still attached. So I have 3 plus or minus 2i. That is all the farther we can go. So we are now finally at our answers. And I have 2 more here, one with the positive, one with the negative. So these are my remaining zeros. This is going to be 3 plus 2i and 3 minus 2i. So I fit those right in the middle there next to a, b, and c. Which means I now have all 4 of my zeros, which I know I needed 4 from the degree. So I have my 0, I have 7, I have 3 plus 2i, and I have 3 minus 2i. For factored form now, I need to take all of those zeros I found and put them back in as factors. So I already did the factors for 0 and 7. They're up here at the top. So we'll start with those. I have x and x plus 7. Now these guys here, we talked about this a little bit yesterday. I'm always subtracting my zeros when I plug them in. So I'm going to go ahead and have x minus that whole thing. So 3 plus 2i. It's one factor. I get the double set of parentheses. And then I have x minus 3 minus 2i. Okay. Now, that actually is a little bit cluttered, and it is kind of a little bit hard to work with. So there is another option here. We know that the x and the x plus 7 still have to be there. Or, sorry, x minus 7. Let me fix that one here. Sorry, this should be a minus. So x minus 7. We know those still have to be there. But that extra piece that we had to multiply by was actually the thing we got out of the division. So if I want to take these two and multiply them together, I'm going to actually end up getting this thing up here. And so we can actually just throw that in here as well. We could call it x squared minus 6x plus 13 is that extra factor that would finish out our factored form. Okay, so this whole problem here is kind of what I should see on your worksheet. There is one of them where you do have to go through the full quadratic formula. Otherwise, the rest you can go ahead and use square roots to solve. And I hope this gives you some more confidence kind of working through these solving polynomials. And again, if you have questions, you're always welcome to ask me in class. Thank you.